Hello and welcome back, everyone. In this video, we're going to be working out this sample test. This is Math 195, Midterm 1. This test covers sections 1.1 all the way to 2.8. I will leave a PDF file of the test in the description box, so that way you can work out the questions on your own, and then you can use the video to kind of check your answers. So let's go ahead and dive into the first problem. So let me go ahead and write this one as our solution file. So for the first problem, we are going to be simplifying this operation. So first thing, of course, you can do it in multiple ways, but I'm going to go ahead and distribute the 2 first. So that will give me a 6 plus 7 over 8 times 2 minus 1 over 3. Now here's 7 over 8 times 2. You can simplify that number by reducing the fraction by 2. So you will have 7 over 4. And now we can combine these fractions by using common denominators. So the least common denominator to combine these fractions would be 12. So I'm going to go ahead and write this over 1 and multiply this by 12 over 12. The second fraction I'll multiply with 3 over 3. So obtain the 12 in the denominator, and this one by 4 over 4. So now they will all have 12 in the denominator. On the numerators, we will have 6 times 12, which is 72, plus, and then 7 times 3, that's 21, and 4 times 1, that's 4, so minus 4. Now, if you combine the numerators, you will have about 89 over 12. And this is not a reducible fraction, so we'll claim this as our final answer. For number 2, we're going to be simplifying this expression by using the laws of exponents. So again, there are multiple ways to do it. I'm going to try to do it the quicker way to get to the answer. So I'm going to go ahead and simplify this first. So I see I have a on the numerator, a on the denominator, and they have exponents. So let me simplify that. So if you have a to the negative 1 over a to the second power, this can be simplified. So the negative exponents, you can drop it in the denominator. So you got 1 over a to the 2 times a to the 1, which is 1 over a to the third. So here's how this is going to look like. The 2, you leave it alone because it just has exponent 1. The a term will simplify to a to the third on the denominator. Now for the b, I'll do the same thing. I have a b on top. Think of it as b to the 1 and b to the negative 8. So what I'm going to do, I'm going to move the negative exponents in the numerator. So that gives me b to the 1 times b to the 8, which is b to the 9th on the numerator. So this would be b to the 9th. And everything gets a power of 4. So what I have done, I have just simplified my variables. Now I'm going to go ahead and combine them further. So I see that I have everything raised to a 4th power. So all I have to do is multiply them. So 2 to the 4th power, so that will be 2 times 2 times 2 times 2. We'll have 16. And then b to the 9th power to the 4th, so that you multiply the exponent, you'll get b to the 36th power. And then for a to the 3rd to the 4th, again, you multiply their exponents, you'll have a to the 12th. And there you have it. This is your simplified answer for this problem. So I have 27 to this exponent. It's negative, so I'm going to write it like this. 1 over 27 to the power 4 over 3. Make the exponent positive. And I'm going to write the exponent as a radical. So this is the cube root of 27, all of it to the 4th power. And we know cube root of 27, that's simply 3. So you will have 3 to the 4th power. And 3 to the 4th power, well, that's going to be 81. So we have 1 over 81 as our final answer. All right, moving on to number 4. Now we're going to be factoring this expression. So I'm going to take out their GCF, or the greatest common factor. So that would simply be, let's take out a negative 5x. So then inside the parentheses, I'll be left with x squared minus 4. And you can always double check by redistributing to see if you have the original. And I do, so I'm good to go on. So then this would factor further, since that's a difference of 2 perfect squares. So we have negative 5x times this will factor into x plus 2 times x minus 2. And there you have it. This is completely factored. That will be our answer to this problem. Number 5, we're going to be simplifying this expression. So let's go ahead and factor everything. So I will go ahead and factor this 2x squared minus 50 in the following way. So we'll pull out 2, then you'll have just x squared minus 25. And x squared minus 25 can be factored further, since that's also a difference of 2 perfect squares, as x plus 5 times x minus 5. So that's for 2x squared minus 50. Now the denominator, where I have x squared minus 16, that's also a difference of 2 perfect squares factored into x plus 4, x minus 4, times. Now the next terms, 3x plus 12, I can take out the 3, then that factors into x plus 4. And x plus 5, well, you can just rewrite that. There's nothing to factor for that. Now here we can start canceling common factors. So I see that I can cancel out x plus 5 with x plus 5, and then x plus 4 with x plus 4. And nothing else cancels from the, we're just going to rewrite them. So you have 2 times x minus 5 times the 3 over x minus 4. And you, of course, you can combine 2 and the 3, so that would give us 6 x minus 5 over x minus 4. Feel free to leave it here, or if you want to continue, distribute the 6, you'll have 6x minus 30 divided by x minus 4. So that will also be a nice, acceptable answer. For number 6, we're going to be performing the addition or the subtraction here. So we have 1 combined with this fraction. So you have to write them in common denominator. So your least common denominator would be x plus 9. So I'll go ahead and multiply 1 top and bottom with x plus 9. So you'll get x plus 9 over x plus 9 minus x plus 1 over x plus 9. Now, since they have same denominators, I can join the numerators as x plus 9 minus x plus 1. So don't forget the parentheses, x plus 9. And here I distribute the negative. So I have x plus 9 minus x minus 1 over x plus 9. Now we can combine. So x and negative x will cancel each other. And 9 minus 1, that's 8 over x plus 9. And here that will be our final answer. Number 7, we're going to be solving this equation. So I can go ahead and divide both sides by 2 or move the 31 to the left, whichever way you like. If you divide, you reduce the numbers, which is nice. So you get x squared is equal to 16. And now I can go ahead and take the square root on both sides. But don't forget, you'll get 2 solutions, plus and minus. So you'll have x is equal to plus square root of 16, which is 4, and negative square root of 16, which is 4. So there you have it. This is your solution. Now, to be super safe with this equation, you could have also solved it as this way. You could say x squared is equal to 16. Subtract 16 from both sides, you get x squared minus 16 equals 0. And then you can factor. So you get your 2 solutions. This will factor into x minus 4 and x plus 4. So you'll get x equals 4 and negative 4. So same thing as this one, except you can do it in 2 different ways. All right, for number 8, we're going to be solving this literal equation. We are solving for the variable r. So I'm going to go ahead and isolate r. We see that r is trapped right here. So to do that, we'll divide by little n and big T on both sides. So your r is equal to p times b over little n times t. So that will be r. For problem 9, we're going to be solving this nonlinear inequalities. We always want to make sure one side is 0. So this is good. Next thing you want to do is factor. So I can factor the left-hand side as x here. And then I need two numbers to multiply to -5, adds up to 4. So that will be +5 and -1. So those are the numbers. So our zeros for this inequality will be x equals -5 and 1. So these are the zeros. So we're going to go ahead and open up the real line and plug the zeros in order. So -5, and let's suppose 1 is here. Now these endpoints or the zeros are not part of our solution because of the inequality. It's strictly less. So we're going to put an open circle at these zeros. So you have three intervals to test. This interval is -∞ to -5, open. Then we have -5 to 1. Then we have 1 to 5, 1 to infinity to test. So for each interval, we're going to pick a test value. So for the first interval, I can test -6. For the one in the middle, we can test 0. And for the last interval, we'll test 2. Something easy and convenient. So I'm going to go ahead and plug them into this expression because it's easy to evaluate. So for x equals -6, we have -6 plus 5, -6 minus 1. So you have -6 plus 5, that's a negative number. Let's write that. And then -6 minus 1, that's also a negative number. So two negative numbers, when you multiply them, it's positive. So this interval, it is positive. Similarly, for x equals 0, we do 0 plus 5 and then 0 minus 1. 0 plus 5, that'll be a positive number. 0 minus 1, that's a negative number. So product of positive and negative will give you a negative number. So here we get negative. And the last one, we're testing 2. So we do the same thing, 2 plus 5 and then 2 minus 1. So 2 plus 5, that's positive. And then 2 minus 1, that's positive. So the product of two positive numbers is positive. So this is positive. And now we choose which interval we want. So this means that our inequality is, our expression in this inequality is less than 0. So that means we want the negative intervals. So where is it negative? Well, right here. So that's the interval we want. So our solution to this problem would be -5 to 1, open at the endpoints. Number 10, we're going to find the center and radius of the circle. We're going to complete the square. So I rearrange the terms in this way. So x squared plus 10x, we leave a space, then we have y squared equals to 0. You only need to complete the square for the x variable since the linear term is missing from the y variable. So you can think of it as it's the y coordinate of the center is 0. So I'll go ahead and complete the square. So I take half of this value. So I take half of that and then I square it. So I get 5 squared, which is 25. So I will add 25 here. And I will also add 25 here to keep it balanced. And now I factor the x variable. So I will have x plus 5 all squared, because that's how you factor x squared plus 10x plus 25. For the y, if you want, you can write like this, y plus 0 all squared equals 25. And 25, you can also write it like this, 5 squared. So now that's in the standard form of a circle, which means the center of this circle is -5 for the x coordinate, 0 for the y coordinate, and the radius of the circle is 5. So there you have it. That's the radius of the circle. So remember this number before we square it, that is your r. For number 11, we're going to find the y-intercept of the line through this these points. So we're going to go ahead and find the slope. So m is our slope. So let's call that slope. And we know this is y2 minus y1 over x2 minus x1. So I'm going to go ahead and label the points. Let's call this x1. Let's call this y1. Let's call this one x2. This is y2. And now we can plug these into our formula for the slope. So you'll have y2, that's -1, minus y1, that's -6, all over x2, that's 8 minus 6. So this will give you a -1 plus 6 over 8 minus 6, that's 2. And negative 1 plus 6, that's 5 over 2. So that is our slope. So now I can use this equation, y is equal to mx plus b, to find the y-intercept, because this number right here, b, that is your y-intercept. So that's one way to do it. Feel free to use other techniques if you have learned them. This is the way I'm going to work it out. So I'm going to go ahead and plug in my slope, which is 5 over 2. Now I have to pick a point, so I'm going to go with, I'll go with this one. It doesn't matter. You can pick either of them. So for x, I'm picking 6, y negative 6. So we have negative 6. For x, we're picking 6 plus b. So let's go ahead and find b. So we have negative 6 is equal to 5 divided by 2 times 6. So that can be reduced to 5 times 3. That's 15 plus b. And I'm going to go ahead and do plus minus 15 on both sides. So you'll have negative 21 is equal to b. So our y-intercept is going to be 0, comma 21, negative 21. That will be the y-intercept of this line. For number 12, we're going to be finding h of 2a minus 1 using this function for h of x. So for h of 2a minus 1, simply what that means is you're going to plug this in where you have x in the formula. So I have x right here. So let's go ahead and do that. So h of 2a minus 1, it's going to be x squared. So x is replaced with 2a minus 1. And we're going to add 1 divided by 2. So that's how you set it up. Now let me just rewrite this. We don't have too much space. Well, now what this means is that you're going to expand that. So 2a minus 1 squared means you have 2a minus 1 times 2a minus 1. So you'll have to expand. So 2a times 2a, that's 4a squared. 2a times negative 1, that's negative 2a. Then you have another factor of negative 2a. You'll have negative 4a. And then negative 1 times negative 1, that's plus 1. So that's what I'm going to replace there. So this will be 4a squared minus 4a plus 1. Then we have plus 1 from before, all over 2. Then we combine like terms. So the only like terms I see here is this. So we will have 4a squared minus 4 plus 2 all over 2. Now we can divide each of these terms by 2. So this divides by 2, this divides by 2, this divides by 2. So that leaves us with our final answer, 2a squared. So 4a squared divided by 2, that's 2a squared, minus 4a divided by 2, that's negative 2a, and then plus 2 over 2, that's plus 1. So there you have, that's your final simplified answer. Number 13, we're going to find the domain of this function, and we're going to express our answer using interval notation. So for this function, which is a negative square root of 2t minus 9, we need to make sure this quantity is always positive. So I want 2t minus 9 to be positive, so it could be 0. And then you start solving for t. So I'm going to add 9 to both sides. 2t is greater than or equal to 9, divide by 2. So t has to be greater than or equal to 9 over 2. So as long as t is greater or equal to 9 over 2, this function makes sense. Therefore, our domain of f is going to be starting from 9 over 2 to infinity. And I put bracket around 9 over 2 because you can set it equal to 0. That's fine. Number 14, there's no graph here, so we can't really find where this function is increasing or decreasing. So we're going to skip this problem for this video. Number 15, we're going to find the net change for this particular function r of t when t is equal to 4 and t is equal to 8. So let's go ahead and label them. So this is going to be your a value, this is going to be your b value. So we know that the net change is given by this formula, f of b minus f of a, where a is the first x value, b is the second x value, as I have labeled it here. Now we're not using f, we're using r, so we're going to evaluate r of b minus r of a. So let's find these values. So what is r of a? Well, a is 4. So we're going to use this function to figure out what the value is at 4. So r of 4 is going to be 4 minus, I replace 4 where t is, so this is 4 over 4, which is simply 4 minus 1, that's 3. So that is our r of 4. And then r of b, it's going to be r of 8. So that'll be 4 minus, replace 8 where t is, so this would be 8 over 4. That would give you 4 minus 2, that's simply 2. All right, now we're ready to answer this. So we know r of b, that's 2, r of a, that's 3. Let's substitute them here. So we will have r of 8 minus r of 4, which is simply 2 minus 3, and that would give us -1. So the net change is -1. Number 16, we're going to be evaluating f of g of 10. So this is a composition of these two functions at 10 using those formulas. All right, so first thing you want to do is figure out g of 10. So g of 10, it's going to be plugging in 10 into g. G is this function, so I will replace x with 10. You'll have 6 minus 10 squared. So that's going to give you 6 minus 100, which is equal to -94. And now this goes inside of f. So we're looking for f of g of 10. So I just computed g of 10, that's -94. So you'll do f of -94. Now this number, -94, will simply go into f. So let's go ahead and do that. So I will have the following now. You will replace -94 where we have x in the f function now. So this is 2 times -94 minus 3. Well, 2 times -94, it's going to give us -188 minus 3, and that's going to give us -191. So that will be our evaluation for f of g of 10. For number 17, we're going to evaluate f inverse of -23 when f of x is equal to this function. All right, so there are, of course, two ways to do this. When this is the input for the inverse function, then that's really the output for the original function. So one way you can do is simply take the function 7 minus 5x and set it equal to -23. Another way you can do this would be to actually find the inverse formula and then plug in -23 into that. I'm going to go ahead and do it this way. I think it's just a bit simpler. Both could be really simpler. No preference why. Let's go ahead and solve for what x value will correspond to -23. So we'll go ahead and minus 7 on both sides. So you will have 23 plus -7. So this will give us about -30 is equal to -5x. And now I divide by -5 on both sides. So that's going to give me x is equal to +6. So there you have it. So we know that our value for f inverse of -23 came from 6. So that will be the answer to this problem. Now let's continue with number 18. So we want to sketch this equation by using transformations of function. So first thing we're going to do is find our basic function. So we're going to start with the graph of absolute value of x. And then it'll go through two transformations. So we're going to apply this one, absolute value of x plus 10, which means we're going to shift left 10 units. And then the second transformation is the -3. So we'll have absolute value of x plus 10. And we're going to go do -3 to that. And this will shift down 3 units. And that will be our final picture. So let me start sketching this for you. So hopefully you know how absolute value of x looks like. So here's our xy plane. So I'm going to position it this way since we're actually going to go down 3 units. So we know absolute value of x looks like this. So it looks like a V. And then this is the absolute value of x. Then we're going to go left 10 units. So let's suppose this is 10. So left 10 units. And then from there, so imagine the V sitting right here, and then it's going to go down 3 units. So I'm just going to go ahead and erase this for clarity. And then we're going to go down 3 units. So suppose 1, 2, 3. So it's right here. So that is our graph. So our graph is just going to go something like this. Let me just call it that. So hopefully you can see the graph. So this is the graph. And let's go ahead and fill in the intercept so it is clear. This point is negative 10 comma negative 3. We need to find the x and y intercepts. So the x-intercepts, we have 2 of them. We're going to set y equal to 0. So you'll have 0 equals absolute value of x plus 10 minus 3. Then I can move 3 to the other side. So this will give me 3 on this side. So this means that we have x plus 10 equals to 3, or we have x plus 10 equals to negative 3. And then we solve both of these equations. This will give me x equals, so I subtract 10, negative 7. And then here I subtract 10, I get negative 13. So x equals negative 13. So this intercept right here, let's suppose that's negative 7. And this one right here is negative 13. Not up to scale, at least we can see the graph. That is good enough. And now we're going to fill in the y-intercept. So the y-intercept is when x is 0. So that's easy to see. When you set x equals 0 to the original right here, you'll get 0 plus 10, which is 10, absolute value of 10. That's 10 minus 3, that would be 7. So this point right here, that will be the y-intercept, 7. So that completes our graph. This is our final equation, y equals absolute value of x plus 10 minus 3. Now, the next thing we want to do for this problem is to state the domain and range using interval notation. So let's go ahead and write that down. So the domain, and plug in anything into the absolute value, you'll always get a real number. So the domain, that's negative infinity to infinity. Now, what about the range of this function? Well, we see that the lowest value the function can obtain is right here, negative 3, and then it just goes up to positive infinity. So the range would be including negative 3 all the way to positive infinity. So that will be our detail for this graph. All right, now let's take a look at the next problem. So number 19, we are going to make another sketch by using transformation again. So now this time we're sketching x squared, and then we'll do transformations to that. So we're going to start with the graph of x squared. And then because of the negative in front of the parentheses, we're going to reflect. So this will be a reflection over the x-axis. So that will give you the negative x squared. And then that plus 1 inside the parentheses, it's going to go to the left. So we're going to go left 1 unit. So that'll give us, take the one we reflected, and then we do plus 1 to that, and that will be the final sketch. So here's our xy plane, and we will see how this looks like. So we know x squared, well, it looks like this. It's a parabola, so it's a U-looking shape. This is x squared. You could do dotted line if you'd like. And then we're going to now shift and reflect and shift. So I will reflect. So when you reflect, it's going to be like this, reflecting over the x-axis. That is the negative x squared. And now we're going to shift 1 unit to the left. So that will put my final picture right here. So 1 unit right here, that's negative 1. And then we just preserve the shape. So something like this. So not the best picture, at least you got an idea how roughly sketch this. So let's suppose that's the final picture. So this is the function f of x equals negative x plus 1 squared. And now you can fill in your intercepts. We already have the x-intercept, so we only need the y-intercept. The y-intercept is when x is equal to 0. When x is equal to 0, you will have 0 plus 1, which is 1 squared. That's 1 times the negative in front. That's -1. There you go. That's the y-intercept. And now we're also going to state the domain and range. So the domain of this function, well, since it's a polynomial, everything makes sense. So therefore, -infinity to infinity. What about the range? So the range, we now look at the y values. So we see that the graph exists from here and then downward. So the lowest we can go is as far as we want. The highest it's going to get to is the x-axis, which is 0. So the low we can go as far as we want to -infinity, and the highest is 0, so including 0. So that will be the domain and range for this graph. Number 20 is the last problem of this test, so let's get to it. So we want to sketch now this function right here. Now we're going to be sketching this by making table of values. So let's do that. The first thing I want to do is replace this piece. What will it become? So we know by definition, absolute value of x is equal to the following. It's going to be positive x when your x values are greater or equal to 0. And it's going to be negative x when x is less than 0. So that's where I'm going to replace it with for those certain choice of intervals. So for x greater than 0, and equal to 0, I will replace my function g of x with x minus. So the absolute value of x gets replaced by x. So it'll be just x minus x, which is equals to 0. And if you make the table of values for x greater than 0, so you pick values for x, and you'll get your g of x values. So we're starting from 0, then 1, 2, and so on. So when x equals 0, g of x is always 0. When x equals 1, g of x is still 0. When x equals 2, it's 0. It's a constant function at 0. All right, so that's for when x is greater than 0. Now, what if x is less than 0? Well, when x is less than 0, my function g of x is going to be defined at x minus. So I replace the absolute value of x now with negative x. So that's going to be a negative x, just like that. And this will simplify the function to 2x, because negative times negative, that's positive. So x plus x, that's 2x. Okay, so now let's go ahead and sketch this. We make a table. I pick some x values, and I get my y values, which are g of x defined by 2x. So let's pick, now again, I'm not going to pick 0 for this one because I already picked for the previous one. But if you want to, you can. It's going to be an open point. Well, the previous one, we already got the close point. So we're actually going to be closing at that point 0, 0. So let's start with -1. So when x equals -1, we have 2 times -1, which is -2. And then when x equals 2, let's see, what's another value we can do? Maybe -2, -2. So 2 times -2, that's -4. And then just keep on going. So hopefully you start to see where this is going, how the graph looks like. So here's our xy plane. So when x is greater than 0, well, that's this side right here. So we are going to draw the constant function 0. So right here, I'll just go this way. So that's when x is greater than 0. And then when x is less than 0, so now we're looking at this piece right here. So we are going to plot the point -1, -2. So -1, -2, perhaps right here. And then -2, -4 further down here. And so on. So hopefully you see that it looks something like this. So it's just a line that continues on this direction. So there you have it. This is our graph for g of x. Alrighty, I hope this solution video made sense to you, and hopefully you found it efficient in your studies. I will see you next time. Take care.